Brennan Aerospace sat on the east side of Cleveland, a sprawling complex of steel and reinforced glass ringed by razor wire. Inside, rows of industrial white light turned night into permanent day. The plant never slept. 3 rotating shifts kept the floor running around the clock, producing some of the most precise metal components in American manufacturing. Trucks came and went at all hours, carrying titanium billets in and finished turbine components out, bound for assembly lines that would eventually put them into the sky. At the heart of the operation stood a 5-axis CNC milling machine, nearly 10 feet tall, weighing more than 8 tons, capable of carving turbine blades out of solid blocks of titanium to tolerances thinner than a human hair. It had cost the company nearly $2 million when it was installed, and it had earned every cent of that investment back many times over in the years since. Engineers spoke about it with a kind of reverence usually reserved for something alive, and for the past 3 days, it had been completely dead. The CNC had shut itself down mid-cycle 72 hours earlier. The main screen flashed a single fault code, E4421. The spindle froze mid-motion, an unfinished turbine blade locked inside the work chamber like a fossil trapped in stone, exactly where it had stopped, exactly as it had been the instant the safety protocol triggered. Since then, 12 engineers had rotated through in shifts of their own, opening access panels, running cable-by-cable diagnostics, arguing over the cause late into each night. They'd swapped signal cables, replaced sensor modules, reflashed the control firmware twice, run every standard troubleshooting procedure in the manufacturer's manual, and several that weren't. Nothing changed. The machine simply refused to wake up, sitting there under the white lights like an animal that had stopped breathing. Every idle hour cost the company more than $40,000 in lost production. Brennan Aerospace was sitting on a $300 million defense contract to supply turbine components for next-generation fighter engines, and the penalty clause for late delivery had already begun ticking upstairs, where executives recalculated the damage in real time, running spreadsheets that grew grimmer by the hour. Down on the floor, the engineers were running out of ideas and out of patience with each other, tempers fraying after 3 sleepless nights of chasing a problem that refused to reveal itself. The Intern. Nobody noticed. Avery Fletcher was 19. He came from the east side of Cleveland, from a block of small brick houses behind chain-link fences and cracked sidewalks. He attended Cuyahoga Community College on a partial scholarship, and one of his professors, recognizing something unusual in the way he understood mechanical systems, wrote him a recommendation for Brennan's summer internship program. 3 weeks earlier, Avery had walked through those factory doors for the first time in his life. His assigned duties were simple: sort spare parts into labeled bins, wipe down tools after shift changes, run paperwork between the floor and the front office. He wore the gray coveralls of an intern, a different color entirely from the blue uniforms worn by the engineering staff. Nobody asked his opinion on anything technical. Nobody expected him to speak in meetings. His badge read, Intern, General Support, and most people treated him exactly the way that badge suggested they should. But Avery watched everything. On his lunch breaks, he stood near the CNC workstations and studied how operators loaded machining programs into the controllers. He borrowed technical manuals off the break room bookshelf and read them cover to cover on the bus ride home. At night, he sketched diagrams into a small spiral notebook, mapping the CNC's entire electrical architecture from memory, cross-referencing it against the manuals until it made sense. By his 3rd week, he understood the machine's systems better than some of the junior engineers who operated it daily. The chief engineer, Craig Lawson, was 50 years old and had been chief engineer at Brennan Aerospace for 22 years. He managed a team of 30 engineers, controlled the entire technical operations budget, and reported directly to the vice president of manufacturing. When Craig made a technical call on the factory floor, nobody questioned it. His word carried the weight of 2 accumulated decades of authority. Craig had opposed the diversity internship program from the very beginning. He called it charity dressed up as corporate responsibility, a waste of floor space, kids with no degrees, no certifications, no real experience, diluting his department. He resented every hour his staff spent babysitting interns who'd be gone by summer's end. When Avery arrived, Craig looked at his badge, looked at his coveralls, and assigned him to the supply closet without a single word. In Craig's mind, Avery was living proof of everything wrong with the program. A community college kid with no degree, no credentials, no business standing anywhere near a $2 million precision machine. The breaking point came in Avery's second week. He was walking past the quality inspection station when he noticed one of Craig's engineers entering calibration parameters into a testing rig. The tolerance value on the screen didn't match the specification sheet pinned to the wall behind the station, a spec sheet Avery had memorized the night before. He stopped, hesitated, then spoke up. "Excuse me, sir. I think that tolerance value might be off. The spec says 0.0002, not 0.002. The engineer stared at him, checked the sheet, checked his screen. Avery was right, a single misplaced decimal, the kind of error that could let defective parts slip straight through inspection. The engineer corrected it without a word of thanks, but Craig saw the whole exchange from 20 feet away. One of his engineers, a man with a master's degree from Ohio State, had just taken a correction from a teenage intern. 3 other engineers noticed too. One raised an eyebrow, another smirked, and muttered something to the man beside him. Craig's face went hard. He said nothing at the time, but from that moment on, Avery Fletcher had a target on his back. Your hands are only good for holding a broom. 3 days after the CNC went down, Craig called a full engineering meeting in the main technical bay. All 12 engineers who'd worked on the machine gathered around a whiteboard while the diagnostic readout from the CNC's last session glowed on the wall-mounted monitor behind Craig. "The primary control board is fried," Craig announced. "We've confirmed it through every diagnostic channel available. It needs a factory replacement from the manufacturer in Stuttgart. Minimum lead time, 6 months. The room absorbed it in silence. 6 months. 300 million in contracts. A penalty clause already counting against them. Nobody had a better answer. Avery happened to be in the room, delivering a parts requisition form when the meeting started. Protocol said he should have dropped it on the desk and left. He didn't. He stood in the back corner, looking at the fault code on the monitor, then down at his own notebook. The numbers didn't match Craig's conclusion. "Sir," Avery said quietly from the corner, "I've been looking at the error logs. I don't think the problem is the control board." Every head in the room turned. Craig's jaw tightened. He crossed the floor with slow, deliberate steps, boots heavy on the concrete. "You think?" His voice was low and sharp. "You think you know more than 12 engineers who've been running diagnostics on that machine for 72 straight hours?" "No, sir. I'm just saying the fault code pattern. Shut your mouth." Craig's voice cut like sheet metal. "You're an intern. You sort bolts. You fetch coffee. You mop floors. You do not open your mouth in a technical meeting. Not in my department. Not ever." The room went still. Avery closed his mouth, his right hand gripping the notebook against his thigh. Craig turned to address the room. "Since our intern has so much free time, let's put it to use." He pointed toward the corridor. "There's a mop in the west closet. The loading dock needs cleaning. That's your contribution here. That's what you're for." 2 engineers near the whiteboard laughed. A third shook his head slowly. One younger engineer near the back, a man named Davis, looked uncomfortable but said nothing. Avery didn't move. His jaw was clenched, his eyes level with Craig's. Then he did something that surprised even himself. He lifted the notebook and held it open so Craig could see the pages. Hand-drawn diagrams of the CNC's entire electrical system. Circuit paths traced in careful pencil, fault trees mapped out with arrows and margin notes. 3 weeks of quiet, methodical study. "I drew the whole system out from the manuals," Avery said. "If we check the encoder..." Craig snatched the notebook out of his hands and flipped through 3 pages. His eyes scanned the diagrams. Detailed, labeled, technically sound. For one brief moment, something crossed his face. Recognition, maybe. Or discomfort. Then it vanished. He closed the notebook, held it out over a patch of oily concrete near the floor drain, and let it drop. It landed face down in a pool of machine oil, the pages darkening instantly. 3 weeks of hand-drawn diagrams bleeding through from the edges inward. "Your hands," Craig said, staring straight into Avery's eyes, "are only good for holding a broom. Don't ever waste my engineer's time again." The room went completely silent. Nobody laughed this time. One engineer looked away. Another studied his own shoes. Davis stared at the notebook on the floor, lips pressed into a thin line. Avery stood still for 5 full seconds. His chest was tight, fists trembling at his sides. He could feel every pair of eyes in the room. 30 people watching a grown man humiliate a teenager, and not one of them saying a word. Then he bent down, picked up the notebook, wiped the oil from its cover with his sleeve, closed it carefully, turned, and walked out of the engineering bay without saying anything at all. Earl Fletcher's 3 Senses Avery learned to fix things before he learned to read. His grandfather, Earl Fletcher, was 72 years old, with hands like weathered oak, thick knuckles, permanent calluses, a grip that could crack a rusted bolt when a wrench couldn't. Earl had served 20 years in the United States Navy as a machinist's mate, keeping diesel engines running on destroyers that sailed through storms most civilians would never survive, rebuilding turbochargers in engine rooms where the heat topped 130 degrees. When a pump failed at sea, there was no parts catalog to order from, no next-day shipping, no calling a specialist. You fixed it with what you had, using whatever scrap and ingenuity the ship carried, or the mission simply didn't happen. That kind of pressure teaches a very particular relationship with machinery, one built on necessity rather than theory. When Earl came home, he opened a small repair shop in his garage on East 116th Street, with a hand-painted sign that read, "Fletcher, fix it." The neighbors brought him everything: lawnmowers with seized pistons, sputtering outboard motors, rattling window air conditioners, portable generators that died during the exact summer storms when people needed them most, an endless parade of small broken machines that kept an entire block of Cleveland running through Earl's patient hands. Earl fixed them all, charging what people could afford, sometimes a plate of food, sometimes nothing at all, because he genuinely couldn't stand the sight of something broken that he knew how to make whole again. Avery started coming to the garage at 8 years old, handing Earl tools, sitting on an overturned milk crate, and watching his grandfather's hands move over engines with a sureness that seemed to come from somewhere deeper than mere knowledge, something closer to instinct honed over decades. Earl was a teacher by instinct, too, though he'd never once used that word himself. He didn't explain with textbooks or diagrams, not at first. He taught with his hands and his senses, and he expected Avery to learn the same way he had, by paying close attention. "Put your ear right here," Earl would say, pressing Avery's small head against a motor casing while it idled. "Hear that ticking? That's the valve train telling you it's out of adjustment. The machine is talking to you. You just have to learn its language." Earl called it his method of the 3 senses, and he drilled it into Avery over years of Saturday mornings in that garage. First, listen. Every machine makes sound, and every sound means something specific. A healthy motor hums evenly, a sick one knocks, clicks, or whines, and each of those noises points toward a different kind of trouble. Second, feel. Place your hands on the metal casing and read the vibration through your fingertips, because a smooth vibration means balanced rotation, while a rough pulse means something loose, bent, or wearing thin. Information no gauge could give you as quickly or as precisely. Third, read the signals. Watch the exhaust color, smell the insulation for the telltale scent of overheating, check the rhythm of a flashing indicator light against what it should be doing. "The machine is always telling you what's wrong," Earl insisted. "Most people just never learn to listen properly, because they've been trained to trust a screen instead of their own senses. Machines lie on their screens," Earl told him once, holding up a cracked distributor cap he'd diagnosed by touch alone, without ever plugging in a single meter. "The sensors see what they're built to see, and nothing more. But your hands are never blind. Your hands will find what the sensors were never designed to look for." By 10, Avery could take apart a small engine and reassemble it correctly without a manual. By 12, he was rebuilding carburetors, rewiring alternators, diagnosing ignition faults that stumped grown men who'd been fixing cars for decades, and charged real money for the privilege. Earl never praised him with big words or ceremony. He'd inspect the finished work in silence, run his thumb along a seam or a connection, nod once and say, "Good. Now do the next one." And somehow that spare acknowledgement meant more to Avery than any amount of gushing praise ever could have. The notebook tradition started when Avery was 12. Earl sat him down at the workbench one Saturday and handed him a blank spiral notebook without any explanation at first. "Write down every machine you fix," he finally said. "What was wrong, how you found it, how you fixed it. Your memory is sharp right now, sharper than you know. It won't always be that sharp. The notebook remembers when you can't." Avery filled 3 notebooks before he finished high school. Lawnmowers, boat engines, generators, air compressors, a commercial dishwasher from the restaurant down the street that had defeated 2 other repairmen before him. Every entry meticulous. Diagrams drawn with a ruler, fault sequences recorded in small, precise handwriting, repair steps numbered and dated like a lab report, though nobody had ever taught him to write one that way. It simply felt like the correct way to preserve something true. Earl never earned an engineering degree. Neither had Avery. But Earl had a motto he repeated so often over the years that it became the rhythm of Avery's whole life, the sentence underneath every other lesson he ever taught. "Every machine wants to run. Your job is to listen to where it's crying for help." That sentence sat written in Earl's own handwriting on the first page of every notebook Avery ever started. The first thing he saw each time he opened a fresh one, a kind of promise he made to himself before he'd even fixed a single thing inside its pages. The notebook Craig Lawson had thrown onto the oily floor was Avery's 4th. It held 3 weeks of careful observation from inside Brennan Aerospace. Wiring paths, system flow diagrams, notes on fault codes overheard during shift changes, questions jotted in the margins that nobody around him had thought worth asking. On page 48 sat a hand-drawn schematic of the CNC's encoder assembly, the one section none of the 12 engineers had thought to check. 2 in the morning, Avery sat alone in the locker room that night, the notebook open across his lap, oil still darkening the edges of its cover. The diagram on page 12, his sketch of the main power relay, was smeared where the stain had spread, though most of the ink beneath it was still legible. He thought about his grandfather, the way Earl's hands moved with a confidence that had nothing to do with credentials or titles. The way Earl never waited for permission to be good at what he did. He just walked up to the broken thing and fixed it. Avery closed the notebook, slid it into his back pocket, and made a decision. The factory floor at 2 in the morning was a different world entirely. Day shift was long gone. The night maintenance crew had finished its rounds and retreated to the break room, and though the overhead lights still blazed white, they never shut off. The roar of production had faded to a low electrical hum. Conveyor belts sat motionless. Tool stations stood wiped clean and locked. The CNC loomed in its bay like a dark monument surrounded by silence. Avery badged through the side entrance. The security guard glanced up, noted the gray coveralls and intern badge, and waved him through without a question. Interns sometimes came in early to prep supply carts. Nobody thought anything of it. He crossed the empty floor, footsteps echoing off the concrete, his notebook in his back pocket still damp at the edges, a small canvas bag of hand tools slung over his shoulder. Hex wrenches, screwdrivers, a pen light, a shop rag, and a dial indicator he'd borrowed off the calibration shelf that afternoon. Nobody had told him to come back. Nobody had authorized him to touch the machine. If Craig found out he was on the floor after hours, his internship would end before sunrise. Avery understood the risk completely. He came anyway. He stood in front of the CNC for a full minute before touching anything. The control screen sat dark, the emergency stop button glowing red. Inside the sealed work chamber, the half-finished turbine blade waited exactly where it had been for 3 days, frozen mid-cut. Avery opened his notebook to the CNC's electrical layout, a diagram he'd drawn over 4 nights, cross-referencing the break room manual against what he'd observed on shift. He traced the circuit path with his finger. Power supply to control board to servo drives to spindle motor to encoder feedback loop. Then he flipped to his notes on the fault code. E4421, primary axis position fault. Every one of the 12 engineers had read that code and reached the same conclusion. The board was sending corrupt position data. The fix seemed obvious. Replace the board, standard procedure. But 2 days earlier, Avery had scribbled a question in the margin of his notebook and underlined it twice. A question none of the 12 had thought to ask. What if the board is reading correctly, but the data it's receiving is already wrong. He pulled a stool to the base of the machine and pressed the auxiliary power button. The diagnostic screen flickered on, casting pale blue light across his face. He navigated to the raw sensor data: axis positions, encoder pulse counts, servo current levels, temperature readings across 6 zones. Everything coming off the control board looked clean. No shorts, no corrupted memory registers, no timing errors in the signal path. The board was doing exactly what it was designed to do. Avery leaned back and stared at the scrolling numbers, then stopped reading them entirely. He did what his grandfather had taught him to do first, every single time. He put his hands on the machine. He pressed his right palm flat against the side panel above the servo drive housing and closed his eyes. The metal was warm from residual heat. He felt the faint vibration of the cooling fans, steady and normal. He slid his hand lower along the casing, normal. Then he moved to the headstock, pressed both palms flat against the heavy iron casting housing the spindle assembly, held still, breathed slowly, and let his fingers read what the screen couldn't show him. There. A faint rhythmic pulse, not the smooth hum of a healthy bearing, but something different. A tiny tick, 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 buried beneath the fan noise, barely perceptible through the thick casting. If the factory had been running at full volume, he never would have felt it. But at 2 in the morning, in the silence, his hands found it. He clicked on his pen light. The encoder assembly sat mounted on the back side of the spindle, behind a sheet metal cover secured by 4 hex bolts. Avery removed them one at a time, setting each on the stool beside him. The cover came off, revealing the optical encoder, a glass disc slightly smaller than a silver dollar, etched with thousands of microscopic lines, read by a sensor head that told the control board the cutting tool's exact angular position at every fraction of a second. He aimed the pen light directly at the mounting bracket, leaning in until his face sat inches from the assembly. And he saw it. The bracket had shifted. Not dramatically, not enough to notice from arm's length, but under the focused beam, it was unmistakable. 2 mounting screws sat slightly off their original bore centers. The encoder disc was tilted less than 1/10 of a millimeter from true alignment. He pulled the dial indicator from his bag, clamped it to the spindle housing with a magnetic base, touched the probe to the face of the bracket, and rotated the spindle by hand 1 full turn. The needle moved 3/1000ths of an inch. Confirmation. The diagnosis. Avery sat back and stared at the encoder for a long, quiet moment. The pen light still trained on the tiny gap between where the bracket sat and where it should have sat. Then he looked down at the concrete around the machine's base, sweeping the beam slowly across the floor. Black rubber scuff marks streaked across the concrete near the left side panel. A forklift had bumped the machine, probably during shipment loading the week before. The kind of minor collision that happens constantly on a busy factory floor and almost never gets reported because nothing visibly breaks. The impact was small enough that no one in the building had felt it. Small enough that the forklift operator himself had likely never even noticed the contact. But it was large enough to shift a precision mounting bracket by 3/1000ths of an inch, and on a machine built to work in increments smaller than that, 3/1000ths might as well have been 3 inches. That tiny displacement was the entire problem, the root of 72 hours of confusion and $120,000 a day in losses. The tilted encoder fed the control board incorrect position data, a lie so small it was almost invisible, but a lie all the same. The board compared incoming data against expected values, found a mismatch it had no way of explaining, and triggered fault E4421, exactly as it was designed to. The safety protocol shut the spindle down to prevent the machine from cutting in the wrong location, potentially ruining a titanium blank worth thousands of dollars, or worse, damaging the machine itself. Every one of the 12 engineers had followed the fault code straight to the control board, because that's where the arrow pointed, because that's what the manual told them to do, because that's what standard procedure dictated in situation after situation for years. But the board was innocent. It was doing exactly what it was built to do, flagging bad data with total accuracy. The real problem sat quietly behind a sheet metal cover, 4 bolts away, that nobody had bothered to remove in 3 straight days of searching. Avery wrote it all down in careful, deliberate handwriting. The dial indicator readings, the exact location and pattern of the scuff marks on the floor, the encoder offset measurement down to the thousandth. He drew the bracket assembly from memory, circled the displaced mounting screws twice for emphasis, and dated the entry the way Earl had taught him to date every entry, without exception. Then he paused, pen hovering above the page, weighing something he hadn't quite let himself think through yet. He could stop here. He could close the notebook, report his findings first thing in the morning, hand it over to whichever engineer happened to be kindest to him, and let the credentialed professionals take the credit and finish the repair properly, the way things were supposed to work. That would be the safe path, the path that kept his internship intact and avoided any further confrontation with Craig. But he heard Craig's voice in his head anyway, flat and dismissive, cutting through every other thought. Your hands are only good for holding a broom. He looked at his own hands under the pen light, stained with oil, calloused from years spent in his grandfather's garage long before anyone at Brennan Aerospace had ever heard his name. The same hands that had rebuilt a boat motor at 13 when the boat's owner had already given up and put it up for scrap. The same hands that had rewired a restaurant's walk-in freezer compressor the previous summer at 2 in the morning, alone, and saved the owner $6,000 in spoiled inventory before the breakfast rush. He opened his tool bag, laid the wrenches out across the shop rag in a neat row, the way Earl always insisted on, and got to work. His first task was proving the diagnosis beyond any doubt, because a theory wasn't worth anything without verification. Earl had drilled that into him just as hard as the three senses themselves. He powered the CNC into full diagnostic mode and pulled up the manual axis control screen, which let him move each axis independently and compare commanded position to reported position in real time. He typed a command, move the x-axis exactly 1 inch to the right. The servo engaged with a soft whir. The table slid smoothly along its linear guides, and the screen displayed the result. Position 1.0000 inches, clean and confident. But the dial indicator mounted on the machine table told a different story entirely. It read 0.996, a 3,000th discrepancy, small enough to miss if you weren't looking for it, and exactly the number he'd already suspected. For most machines in most industries, 3,000ths of an inch is nothing, a rounding error, invisible to the naked eye and irrelevant to function. For a 5-axis CNC, machining turbine blades to aerospace tolerances, where the acceptable margin is measured in 10,000ths of an inch, it was a catastrophic failure. The difference between a blade that flew safely for thousands of hours and one that failed under stress at 30,000 feet. He repeated the test on the y-axis, dead accurate. The z-axis, dead accurate. The A and B rotary axes, both comfortably within spec. The error lived only on the x-axis, the one axis whose position was controlled by the exact encoder he'd just examined under his penlight 20 minutes earlier. There was no ambiguity left, no room for doubt. He mapped the entire fault chain in his notebook, arrows connecting each link in a sequence that now looked almost obvious once you saw it laid out in full. A forklift impacts the machine base. The impact shifts the encoder mounting bracket by 3,000ths of an inch. The shifted bracket tilts the optical disc off true center. The tilted disc sends slightly incorrect position pulses to the control board. The board compares the incoming data to expected values and detects a mismatch it cannot resolve. The safety firmware triggers fault E4421 and shuts the spindle down to prevent cutting with bad position data. 6 steps, each one small on its own, each one perfectly logical in isolation, and together they'd killed a $2 million machine for 3 straight days and nearly cost the company a $300 million defense contract along with it. And the reason 12 engineers with advanced degrees had missed every single one of those 6 steps was painfully, almost embarrassingly simple. They trusted the fault code completely, the way they'd been trained to trust it through years of formal education and standardized procedure. It said, primary axis position fault, so they went straight to the electronics, control board, servo amplifiers, signal cables, firmware, every digital layer of the system, and never once considered that the error might be purely mechanical, might have nothing whatsoever to do with electronics at all. Never once put their bare hands on the machine and simply listened to what it was trying to tell them. Earl Fletcher would have found it in an hour, maybe less. Avery was certain of it, had been certain of it from the moment his palm first felt that faint ticking through the iron casting. He remembered a day at the garage when he was 14. A customer had brought in a table saw that kept tripping its circuit breaker every time he used it, a maddening intermittent fault that had already sent him to 2 other repair shops with no luck. Avery checked the motor windings with a multimeter, normal resistance. Tested the power cord end to end, no shorts anywhere. Examined the switch mechanism under a magnifying glass. Clean contacts, no corrosion. Every electrical test in the book came back perfectly fine, and he'd been completely stuck, running out of ideas exactly the way 12 grown engineers had just spent 3 days running out of ideas. Earl had walked over without being asked, wiped his hands on his coveralls, placed his palm flat against the base plate, held it there in silence for 5 full seconds, and looked up with the same calm expression he wore for every repair, big or small. Feel that? The motor mount bolt is loose. The motor vibrates against the housing every time it spins up. Vibration generates heat at the contact point. Heat breaks down the wire insulation right where it passes through the housing. Insulation fails. Current leaks to the frame. Breaker trips. Nothing wrong with the electrics at all, not one thing. Whole problem's one loose bolt somebody forgot to torque down at the factory. A loose bolt killing a table saw. A bumped bracket killing a $2 million CNC milling machine. The same underlying principle, separated by 40 years, a modest garage, and $2 million in precision German engineering. The machine tells you where it hurts, every single time, without fail. You just have to be the kind of person who puts your hands on it first and actually listens to the answer. Building the shim. The second task was the repair itself, and here Avery had to improvise. The encoder wasn't broken, the optical disc was clean, the sensor head reading correctly. The problem was the mounting bracket. The impact had shoved it out of position, and the mounting holes were slightly worn, no longer capable of holding the bracket in its precise original alignment. He needed to compensate for the displacement. He checked the spare parts inventory at the nearby workstation terminal. Brennan Aerospace didn't stock encoder mounting brackets for this particular CNC model, a specialized machine from a German manufacturer, with replacement parts requiring a direct factory order and an 8 to 12 week lead time. But Avery didn't need a new bracket. He needed to shim the existing one back into alignment. A thin metal spacer placed behind the bracket on its low side to push it back where it belonged. The shim needed to be exactly 3/1000ths of an inch thick. No more, no less. He walked to the salvage yard at the back of the plant, the graveyard of old equipment, decommissioned CNC units missing panels, retired lathes stripped of their motors, aluminum extrusions from a tooling changeover the year before. Avery knew this area well. Sorting and cataloging salvage had been one of the first tasks Craig assigned him during his opening week. 20 minutes of searching turned up an encoder assembly pulled from a retired 3-axis CNC. Different manufacturer, different generation. But the mounting hardware, alignment dowel pins and shoulder bolts, was close enough in size to work as reference tooling for the realignment. He carried the salvaged parts back to the 5-axis machine and set them on the workbench beside his tools. Then he picked up a scrap piece of aluminum plate from the salvage bin, roughly 4 inches square, a 1/4 inch thick, far too thick for a shim, but flat, clean, and machinable. He marked the outline with a fine-tip scriber and cut it out with a jeweler's saw, a thin-bladed hand tool built for precision metalwork. 10 minutes of slow, careful strokes. Then he began filing. He braced the aluminum against the edge of the workbench and worked it with a fine-cut mill file, long, even strokes. After every dozen passes, he stopped, measured the thickness with a micrometer, read the barrel to the nearest 1/1000th. File, measure, file, measure. The factory floor was silent except for the rhythmic scrape of metal on metal and the soft click of the micrometer's ratchet. Avery's hands were steady, his breathing slow. He wasn't rushing. He wasn't nervous. This was the work he'd trained for his entire life, diploma or no diploma. 40 minutes later, the shim measured exactly 3/1000ths of an inch, uniform across its whole surface. He checked it 3 times, held it up under the white lights to inspect the edges. No burrs, no taper, clean enough to satisfy any quality inspector. He placed it behind the encoder bracket on the low side, inserted the salvaged alignment dowel pins to lock the bracket's lateral position, and tightened the mounting screws to the torque spec listed on page 43 of the maintenance manual he'd long since memorized. Then he reached for the dial indicator one more time, mounted it on the spindle housing, touched the probe to the face of the encoder disc, and rotated the spindle slowly by hand. One full revolution. The needle barely moved. Total indicated runout. Less than 0.5 of an inch, well within manufacturer specification. Avery's hands were black with oil and fine aluminum dust. A small cut had opened on his right index finger during the filing, a thin line of blood mixing with the grease on his skin. He didn't notice. He wasn't looking at his hands. He was looking at the dial indicator. It was perfect. The machine wakes up. The third and final task mattered more than anything that came before it, bringing the machine back to life. Avery replaced the sheet metal encoder cover, tightened the 4 hex bolts, and wiped his hands on the shop rag until most of the grime came off. Then he walked to the main control panel and pressed the master power switch. The screen flickered on. The boot sequence scrolled through its initialization checks. Cooling system active, hydraulic pressure building, servo amplifiers online, each system reporting in one by one, like a crew calling roll. Then the moment came. The servo drives energized. The spindle motor began its warm-up rotation, and the sound filled the empty factory floor. A deep, smooth hum, rising in pitch as the spindle reached operating speed. No vibration, no clicking, no stuttering. Just the clean, powerful sound of a precision machine running exactly the way it was designed to run. He ran the automated self-test sequence from the diagnostic menu. The machine moved through its full range of motion. X-axis nominal, Y-axis nominal, Z-axis nominal, A and B rotary, axis nominal. Every position value returned green. Every temperature reading fell within the normal band. Every servo current trace ran smooth and flat. When the test cycle completed, a single line appeared at the bottom of the screen. All parameters nominal. Ready for production. Avery stood alone in front of the machine. $2 million of equipment humming quietly under the white lights, the turbine blades still waiting inside the work chamber, ready to be finished on the next production run. 3 days of downtime, over $1 million in accumulated losses, 12 engineers, a $94,000 replacement board already on order, all of it unnecessary. The problem had been a 0.003 of an inch misalignment, solved with a hand-filed scrap of aluminum weighing less than an ounce. He opened his notebook to the last unused page and wrote it all down. The date, the machine model, the fault code, the root cause, the repair procedure. He drew the encoder assembly with the shim in position, noted the final run-out measurement, closed the notebook, and slid it into his back pocket. Then he sat back down on the stool and waited. He didn't call anyone. He didn't send a text or an email. He just sat there in the white light, hands on his knees, oil under his fingernails, blood drying on his index finger, staring at the machine 12 engineers had declared dead. It was 3:45 in the morning. Harold Brennan. Harold Brennan had built his company out of a 2-car garage in 1986, starting with a second-hand lathe and a drill press he'd bought at auction, for less than he'd hoped and more than he could really afford, rebuilding both piece by piece before he ever machined a single part for a paying customer. His first contract was making valve stems for a local plumbing supplier. No degree, no investors, no connections in the industry, just hands and patience and a stubborn refusal to accept that a small garage operation couldn't eventually compete with the larger shops across town. 40 years later, Brennan Aerospace employed over 2,000 people across 3 buildings and held defense contracts that kept fighter jets in the air over places most of his employees would never visit. Harold was 62 now, and Forbes had profiled him twice, calling him a self-made success story, a rare thing in an industry increasingly dominated by inherited capital and engineering pedigrees. But old habits die hard, and 2 or 3 times a month he still drove to the plant before sunrise, unannounced, no schedule, no assistant trailing behind him, walking the floor alone in his own work boots, checking machines with his own hands, talking to the night crew about their kids and their overtime, and whatever else was on their minds. He called it the only honest part of running a company anymore, the part where nobody had time to prepare a version of the truth for him. At 4 in the morning, Harold badged through the east entrance the same way he had 1,000 times before. The night security guard nodded without surprise, barely glancing up from his crossword. Harold walked toward the main production bay with a paper cup of coffee in one hand and his car keys in the other, footsteps unhurried, and made it 15 steps before he stopped cold, coffee halfway to his lips. He heard the CNC running. He knew that machine had been dead for 3 days. The production loss report sat on his desk in red ink, a document he'd read and reread until the numbers had practically burned themselves into his memory. He'd already signed off on an emergency purchase order for a replacement control board. $94,000, 6 months of waiting, a delay that could cascade through the entire defense contract and potentially cost the company far more than the board itself. He'd spent 2 nights lying awake calculating whether the penalty clause would cost them the entire contract or just a devastating chunk of it. But right now, at 4 in the morning, in a factory that should have had one silent, useless corner, the spindle was turning. He could hear the hum from clear across the bay, that deep, smooth, unmistakable sound of a precision machine operating exactly as it should, a sound he'd know blindfolded after 40 years in this business. Harold set his coffee down on a tool cart without really looking at it and walked quickly toward the CNC bay, boots echoing off the concrete in the empty space, his pulse picking up in a way it rarely did anymore at his age. He turned the corner and stopped. A young man in gray coveralls sat on a stool in front of the machine, hands covered in oil and fine aluminum dust, a small notebook open across his knee, his posture relaxed in the particular way of someone who had just finished a long and satisfying piece of work. Behind him, the main control screen glowed green, all 5 axes reading nominal. The production readiness indicator lit steady and bright. Harold didn't recognize him. With 2,000 employees scattered across 3 shifts, that wasn't unusual in itself, but something about the scene struck him as deeply out of place all the same. "Who are you?" Harold asked, his voice carrying easily across the empty bay. "Who authorized you to be on this floor at this hour?" The young man stood, straightened the front of his coveralls with a quick, almost reflexive motion. Tall, lean, his eyes steady despite the obvious surprise of being caught somewhere he clearly wasn't supposed to be. "Nobody authorized me, sir. My name is Avery Fletcher. I'm a summer intern." "An intern?" Harold looked past him at the CNC screen, green across every single parameter. Exactly the readout he'd been dreaming about for 3 sleepless nights. Then back at the young man's hands. Oil, metal dust, a small cut on one finger that had clearly been bleeding at some point. "My engineering team declared that machine dead yesterday afternoon. Told me the control board needed a factory replacement out of Germany." "The control board is fine, sir," Avery said, meeting his gaze without flinching. "It was never the problem." Harold set his keys down on the workbench beside him, deliberately, the way a man sets something down when he intends to stay a while. "Show me." Avery opened his notebook and walked him through the entire diagnosis, step by step. The fault code and why it had been misleading, the forklift scuff marks on the floor, the encoder bracket displaced by 0.03 of an inch, the false position data feeding into a perfectly functional control board, the whole cascade that had turned a simple mechanical displacement into what looked like a catastrophic electronic failure. He showed Harold the shim he'd hand-filed from scrap aluminum, the salvaged alignment pins, the dial indicator readings before and after the repair, and pointed to the test results glowing on the screen. Harold listened without interrupting. He'd built machines with his own hands for 40 years. He understood every word Avery said. More than that, he understood exactly what it took to see what 12 experienced engineers had missed. When Avery finished, Harold walked to the machine, pressed his hand flat against the side panel, felt the vibration. Smooth. He opened the encoder cover, looked at the hand-filed shim, ran his thumb along its edge. Precise. He closed the panel and turned back to Avery. Where did you learn to do this? My grandfather, sir. Earl Fletcher, machinist's mate in the Navy. Had a repair shop in his garage. And what did he teach you? Avery paused. He taught me to listen to the machine before I look at the screen. Harold stared at him, because he'd heard those exact words before. Not those precise words, but the same truth underneath them. 40 years earlier, in a cold garage with a used lathe, a young Harold Brennan had taught himself the very same lesson. Trust your hands before you trust the readout. Feel the vibration. Listen to the sound. The computer shows you what the sensors can measure. Your hands show you what's actually there. Harold looked down at the notebook, the oil stains spreading across its cover, the wrinkled pages, and picked it up carefully. He turned to page 48, the encoder diagram that had led to the fix, and studied it for a long moment. Why is this notebook covered in oil? He asked. Avery looked at the floor. He didn't answer. Harold closed the notebook, held it in both hands for a moment, then handed it back gently, the way you'd return something valuable. Go home, he said quietly. Get some sleep. I need you in the main conference room at 9 sharp. The reckoning. At 9 that morning, the second-floor conference room was full. Craig Lawson sat at the head of the long table, coffee untouched in front of him, his 12 engineers filling the chairs on either side, some with laptops open, others with printed diagnostic reports stacked in front of them. Avery stood near the door in clean coveralls, unsure if he was even allowed to sit. Nobody had offered him a chair. Harold Brennan walked in last. He didn't take a seat. He stood near the whiteboard at the front of the room and let the silence hold for 3 full seconds before he spoke. Avery. He gestured him forward. Come up here. Show everyone in this room what you showed me at 4 o'clock this morning. Avery walked to the whiteboard and picked up a blue dry erase marker. His hand was steady. He drew the CNC's encoder assembly from memory. The mounting bracket, the optical disc, the alignment dowel pins, the sensor head, then the fault chain. Forklift impact, bracket displacement, tilted encoder disc, corrupted position data, false fault code, safety shutdown. He wrote out the measurement values, explained the shim repair, described how he'd confirmed the diagnosis using the manual axis test and the dial indicator. The room stayed completely silent. 12 engineers watched a 19-year-old intern in gray coveralls explain, clearly and methodically, the exact problem their entire team had failed to solve in 72 hours. When Avery set the marker down, one of the senior engineers leaned forward. You found this by touching the machine? By touch first, Avery said. Then I verified it with the dial indicator and the axis position test. Nobody spoke. Craig Lawson stared at the whiteboard, his face giving away nothing. Harold stepped forward. Effective immediately, Avery Fletcher is transferred out of the intern services pool and into the engineering division. He'll hold the title of technical engineering intern with full floor access and equipment authorization. He paused. Brennan Aerospace will fund a full scholarship for Avery to pursue a bachelor's degree in mechanical engineering at Case Western Reserve. Tuition, fees, and books, for as long as he stays enrolled. Harold looked directly at him. And when you graduate, there will be an engineering position at this company with your name on it, if you want it. Avery's hands tightened around the marker. His throat closed. He swallowed once, hard, and nodded. Yes, sir. I want it. Harold didn't leave the room. He turned to face Craig Lawson directly. Craig, let me ask you something. 12 engineers under your direct supervision examined that CNC for 72 consecutive hours. They reported to me that the primary control board was irreparably damaged and required a factory replacement out of Stuttgart. Based on that report, I approved an emergency purchase order yesterday. Do you know what that board costs? Craig's jaw tightened. $94,000, sir. $94,000, Harold repeated. For a component we never needed, because the actual failure was a mounting bracket displaced by 0.03 of an inch from a forklift impact, a mechanical fault diagnosed and repaired by a 19-year-old summer intern using hand tools and a scrap of aluminum out of our own salvage bin. The room went motionless. Engineers stared at the table, at the walls, at their own hands. Nobody looked at Craig. Craig opened his mouth. Sir, The fault code pointed directly to the primary access controller. Standard diagnostic procedure dictates you follow the fault code to its indicated source. Standard diagnostic procedure, Harold said evenly, cost this company 3 days of production downtime and over $1.2 million in losses. It nearly triggered the penalty clause on a contract that employs 800 people in this building. Your standard procedure told you what the computer said. This young man told you what the machine said. There is a meaningful difference between those two things. Craig closed his mouth. His fingers gripped the armrests of his chair. Harold continued. I spoke with several members of your team this morning before this meeting. One of them described an incident that took place yesterday afternoon in the engineering bay. During a technical meeting, Mr. Fletcher attempted to suggest that the fault might not originate in the control board. He was ordered to leave the meeting. He was told his only appropriate task was mopping floors. Harold paused, his voice remaining level even as its weight filled the room. His personal notebook was taken from his hands and dropped into a puddle of machine oil in front of the entire team. The same notebook that contained the diagrams which led to the correct diagnosis. Several engineers shifted in their seats. Davis, the younger engineer, looked down at the table. Craig's face had gone pale. Is that account accurate? Harold asked. Craig took a breath. He's an intern, sir. Interns aren't credentialed to participate in technical diagnostics. He's the only person in this building who fixed the machine. Harold let the sentence sit there in the silence like a dropped hammer. He placed both hands flat on the conference table and leaned in slightly. I'm ordering a comprehensive internal review of the engineering division's leadership practices and diagnostic protocols. It will be conducted by an independent outside firm, and it will assess how technical input from every team member is handled, regardless of title, rank, or employment status. He straightened up and looked at Craig one final time. You've been here 22 years, Craig. That's a long time. Long enough to know that this company was built by a man who started with no degree, no credentials, and no investors. Just a used lathe and a pair of hands that knew what they were doing. You should have recognized what was standing right in front of you. He held Craig's gaze a beat longer. You didn't. Harold turned and walked out of the conference room. Craig sat alone at the head of the table long after everyone else had cleared out. The whiteboard behind him still bore Avery's diagram. The encoder bracket, the shim, the fault chain, all still in blue marker. 22 years of authority, and now the walls were closing in. Not because anyone had conspired against him, but because he'd looked at a 19-year-old kid with oil-stained hands and seen nothing worth hearing. The investigation would find whatever it found. Craig already knew there were other things buried in those years. Shortcuts nobody had followed up on, junior engineers' concerns filed away and forgotten. He'd built a department where only one voice ever mattered, and kingdoms built on arrogance rarely survive the light. The phone call. That evening, Avery called his grandfather from the parking lot of Brennan Aerospace. Earl picked up on the second ring. How's the job? Avery told him everything. The machine, the encoder, the shim he'd filed from scrap aluminum at 3 a.m, the scholarship, the seat waiting for him in engineering. Earl went quiet for a moment. Then he asked the only question that ever really mattered to him. Did you write it down? Avery laughed. Every detail, Grandpa. Good. That's all that matters. Avery looked down at the notebook resting on his knee. The oil stain still dark across its cover, the pages still wrinkled from grease. But every diagram inside it was intact. Every fix was recorded. From an oily factory floor to an engineering future. One notebook and one pair of hands that had never once stopped listening.